And good morning. It is my pleasure to welcome you all to the Sigmafine Virtual Summit 2020. Today, we have many Sigmafine users online, as well as many professionals who are approaching the summit to learn more about Sigmafine. My aim today is to introduce the theme of the summit, transforming data into digital assets, and see with you how Sigmafine can support several process industries in improving the quality of their process data. I will also introduce the new generation of Sigmafine, called the Sigmafine Hub, which is going to bring a new and enhanced Sigmafine user experience. And finally, I would like to give you some insights related to the summit itself and how the Sigmafine community has been evolving along the recent years. So the journey of digital transformation started several decades ago with the beginning of the information era. Every decade since then has brought its lot of technological changes, some more disruptive than others. In the last decade, we saw big data, cloud, and industrial IoT concepts evolving and becoming more tangible and more practical, thus enabling new challenges such as digital transformations, smart manufacturing, predictive analytics, machine learning, and more. And in parallel and throughout these decades, the object of our analysis evolved. So we started with individual data elements, which were digitized, and later collected and digitalized in relational databases and time series databases called process historians. Today, the object of our analysis is usually a dataset, which originates from multiple data sources or databases, and which has to be turned into a usable digital asset. So what do we mean by a digital asset? Being digital refers to data information stored digitally, and being an asset refers to anything that can be owned and controlled to produce a positive economic value. Consequently, a digital asset refers to data information we own and control and use to generate tangible benefits. The advent of digital assets has resulted in the emergence of a new practice called infonomics, which is the study of the principle governing the evaluation and deployment of digital assets and giving economic significance to information. And the issues we have to face in producing digital assets are mostly depending on the data defects, which can occur all along the data transformation chain. Such defects may be related to the instrumentation level, to data acquisition and data infrastructure, as well as to inappropriate data calculation and transformation, and obviously to human data manipulation. These data defects bring us to a set of challenges which we have to face in order to establish a data quality improvement practice. Firstly, the precision of measurement is inherently limited, and measurement, when considered around an envelope of analysis, never add up. Then we have to deal with the potential error introduced by human manipulation. So we would like to automate the process as much as possible and make the curation of defects a sustainable practice, and hopefully use data quality outcomes to drive investment back to the measurement systems. So definitely, we want to create a usable digital asset with the higher degree of accuracy and the lower possible degree of uncertainty, ready to be consumed by the digital value chain. And to face the challenges above introduced, Sigmafine relies on a model-driven data quality approach. So the center of the transformation model in the Sigmafine world is a model. But what is a model? We can say the model is a conceptualized representation of the subject of our analysis. It can embrace an entire production facility, or a single process unit, or a utility network, or a distribution network. It embeds the engineering and operation expertise of the company, and when required, it may include even business and/or compliance rules. Such model is typically fed by the real-time data infrastructure, with process data, and where required with laboratory data, business transaction, and more. And for all the reasons we introduced above, we cannot ignore that each piece of information entering the transformation chain cannot be assumed to be exact or correct. It brings with it an inherent degree of uncertainty. So to minimize the effect of such uncertainties around the model, Sigmafine runs a set of analytics whose objective function is to find a coherent solution to a measurement system envelope, minimizing the uncertainty of the resulting dataset. By the way, this has been the job of Sigmafine and its user for almost 3 decades now. The output of this transformation process is not just a union of multiple data streams, but a coherent dataset representing the best statistical dataset approximating the true value of our measurement system. For those who know Sigmafine, In Sigmafine terminology, this is defined as a case. Indeed, it is a digital asset embedding both the so-called reconciled measurement and the trackable statistical data indicators, which can then be consumed for several purposes, including but not limited to improve operational performance, to support accounting and finance duties, to achieve compliance to regulations. However, it is important to notice that this cannot be a one-shot achievement, but it must be turned into a practice to be managed over time. So the set of cases or digital asset produced over time is the foundation for a validated and controlled and measurable system of record for the company. And the adoption of a data quality practice is the one allowing to minimize the uncertainties, avoiding financial losses, and hopefully maximizing financial gains, which indeed bring us back to the definition we gave of digital asset. So on these 3 days, we have seen, and we will see today, more Sigmafine users have been treating the topics of Sigmafine data quality indicators as a key to build a sustainable practice. As an example of monetization of data quality practice, we are reporting a couple of cases. So the first one is related to a large refining and petrochemical complex, where the identification of small deviation in the measurement can lead to relevant savings, especially when related to high-valued product streams or inventories. In this case, the model representing the whole facility is made by thousands of interconnected nodes, and by tracking the data quality statistical indicators and analyzing them over time, the company is able to detect and handle data disturbances generated by meter drifts or by unit shutdowns. Instead, in the second case, which is limited in extension if compared to the first one, but equally meaningful for our discussion, we see this is related to a chemical distillation column. The related model in this case applies both mass and energy constraint to produce a reconciled digital asset, so improving both the accuracy of calculated KPIs, which in this case is related to the energy-specific consumption, and the uncertainty of the same KPIs, which is narrowed as a result of the data quality improvement process. Again, such improvements can then be converted into economics to express the actual saving or avoided losses. So those are just a couple of examples coming from the oil downstream industries. However, Sigmafine is already in use in a broader range of industries beyond refining and petrochemicals, including oil and gas production, LNG production and regasification, metals and mining, power as a utility, chemical, fertilizers, pharma, and more. All these industries count on the best possible data quality to be timely available to support the decisional processes. And how Sigmafine enables so many industries in adopting a data quality process. At first, the core of Sigmafine analytics is data reconciliation, which constrain the data with first principle equations such as conservation of mass, volume, energy, and mass component, while simultaneously minimizing the uncertainty associated with the measurements. Then, on top of data reconciliation, tracking and genealogy capabilities allow to infer physical properties, grades, stream qualities, as well as ownership or other business categories. However, Sigmafine is not only a set of advanced algorithms. Its foundation is an asset database which is fully configurable, customizable, and extensible to adapt to the need of different industries. And Sigmafine can scale from very small model of few hundreds assets to very large scenario where models are composed of tens of thousands of assets. And it executes across a wide range of time resolution, hourly or shorter, daily, monthly, on event, or by batch, to meet the requirement of the most demanding use context. Finally, it's very flexible in terms of integration with the customer infrastructure, able to interface bidirectionally with the disparate set of data sources and data repositories. Also, we would like to encourage you to check for success story about process industries other than yours. In fact, the versatility of Sigmafine demonstrated that certain practices initially implemented by one industry have then been successfully adopted by other industries. Here we have the case of tracking algorithms. They were initially used in the 90s to track crude oil mixture in the refineries. Then the use is expanded to all hydrocarbons, covering intermediates and finished product. And later on, with the addition of component balancing, Sigmafine was applied to the mining and metals industry. On last year, the addition of the capability to track and estimate physical properties opened the door to new use cases in petrochemicals, like in the production of the aromatics. And then the combination of tracking applied to shortened analysis period enabled supporting the life science industries to solve cost allocation and waste management problems. More recently, Sigmafine tracking was applied also to blending and formulation on NPK fertilizing product. And we see now a hot topic today, their application to circular economy practices in order to track the usage of recycled raw materials all along the production chain. There are just a few examples. We invite you to check out our user presentation from the summit and the previous summit to discover other use cases. And now we have come to one of the most relevant topics for the summit, the launch of the new generation of Sigmafine, the Sigmafine Hub. It might be that most of you don't know Sigmafine has been used by the process industries for over 25 years, since its introduction in the first 90s. Sigmafine was initially created for the refining industries to support profit improvement plans. And then in 1999, it was acquired by Osisoft, the makers of the PI system, and it was used as the reference model to develop the PI asset framework infrastructure. Then in 2010, it was acquired by Pinsot, which expanded the product with new analytics, diagnostic, and integration capabilities. And finally, today, Pinsot is glad to announce the launch of the new Sigmafine Hub generation with the aim to support the transformation of data into digital asset. So the demand for an improvement data management practice, for a linear and smarter user experience, for a scalable and easy deployable technology led Pinsot to take the journey to the Sigmafine Hub. We believe this is a milestone in the Sigmafine history and a major event for all the Sigmafine community. And to make it simple, I just would like you to go through this video introducing the Sigmafine Hub.
It is my pleasure to introduce Sigmafine Hub, the next generation Sigmafine, a digital asset factory for the process industry. Today, digital transformation is top of mind for everyone in the process industries. It is transforming how we look at plant operations. It is impacting how we work and collaborate. It demands new skills in data engineering and data science. It calls for new sensors, edge data processing, and new management practices. It is changing how business processes are designed and run. Digital transformation impacts the entire value chain in the process industries and is creating new requirements for improved data management. At PIMSoft, we are responding to this challenge by extending the capabilities of Sigmafine. Our first challenge in digital transformation is the transformation of raw data, measurements, signals, and events originating from sensors, control systems, and other systems into digital assets. Once transformed, we can manipulate, analyze, share, distribute, and reuse these assets to further our business objectives. The possibilities are endless. According to the World Economic Forum, a majority of digital transformation initiatives in the process industry are data-driven. This means that massive amounts of data must be turned into usable digital assets. Enter PIMSoft's Sigmafine Hub, a digital asset factory for the enterprise. Let's make one point clear. Sigmafine Hub is not a new Sigmafine. Sigmafine Hub is a new Sigmafine experience, shifting the paradigm of data validation and data reconciliation to address the challenge of digital transformation and advanced manufacturing strategies like Industry 4.0. We also call it a factory because Sigmafine Hub's new capabilities can simplify, accelerate, and automate the transformation of process data into digital assets. So what is this new experience? Sigmafine Hub is a web application server which integrates with Sigmafine Server and a collection of web apps introducing new capabilities while preserving the investment made in building models in Sigmafine. During this summit, you will discover the first web app to be launched in 2020, Sigmafine Hub Visualizer, and get a preview of Sigmafine Hub Studio. To find out more, attend the presentation and schedule an interaction by clicking on the button before you exit the virtual Expo Pod. Thank you for stopping by and participating in the virtual Sigmafine Summit. We hope you're finding the experience valuable.
Okay, so later today, please don't miss the presentation by Massimo and David, who will introduce the Sigmafine Hub as the digital asset factory for the enterprise. Okay, finally, I would like to guide you through some insights related to the summit 2020. First, I would like to say that the difficult times we are all living brought us to the decision of turning the Sigmafine Summit into a virtual event. and we were uncertain about the new format since all previous Sigmafine events were in the form of in-presence conferences. But today, we are very glad to share that the summit can count on more than 420 registrations, including representatives from Sigmafine users, partners, and companies who are interested in learning more about data quality and Sigmafine. All the process industries are represented with an historical predominance of the oil downstream industries. And beyond the process industries, we also have obviously professionals from information technology, software, and the engineering sector. Also, we would like to share an interesting perspective with you, which is related to how the Sigmafine community has been evolving along these years. So we made the exercise of segmenting the job titles of the summit attendees, which is giving us the following map. And this is making evident how data quality improvement cannot be achieved by single software or through a single type of expertise. Rather, it is the result of a well-defined practice which involves several types of expertise in different areas, such as the instrumentation and automation, IT and data application infrastructure involving the PI system as well, accounting, planning, process engineering, operational excellence. And it is also evident how data-related professions are becoming more and more a part of this scenario. So it was not surprising to see profession titles such as statistical engineer or data management expert. And the Sigmafine community will not be complete without the contribution of a set of companies enriching the Sigmafine offering with their domain expertise and complementary solutions. So we want to thank our sponsors who joined us sustaining the summit, and we invite you to visit the sponsor of Virtual Expo at the Sigmafine Summit event website to check for the solution and expertise provided by our network of partners. You can find both Sigmafine partners who are delivering Sigmafine expertise and solution in specific geographical areas or on specific industry domains, as well as ecosystem partners whose value proposition complements Sigmafine with specific digital solution in the field of advanced analytics and operational awareness. We have also a couple of interventions by Alliance's partners, Emerson and OSI. In the APAC session, Emerson explained how companies can achieve pacesetter performance in loss management using the right measurements and the data management technologies. And later today, Osisoft will discuss a layered approach to improve data quality as a prerequisite to support digital transformation initiatives. Finally, we would like to thank all our Sigmafine users who share the success story from different industries with the rest of Sigmafine community. We really appreciate your efforts and your valuable contribution. There are several industries represented, and it will be interesting to check how Sigmafine has been shaped in a different way to produce digital assets according to the requirement of each specific industry. So this concludes my introduction. I would like to welcome you again, and please enjoy the Sigmafine Virtual Summit 2020. Thank you.